Our next speaker is Jakob Clausen, Manager of Marketing Analytics at Zynga, with his talk, iOS14 or How I Learned to Stop Worrying and Love the SKAdNetwork. Thanks for joining us today, Jakob.
Hi, my name is Jakob Clausen, and I'm the head of marketing analytics at Zynga, one of the world's largest game publishers. And today I want to spend some time talking about iOS14. Specifically, I want to talk about the introduction of the SKAdNetwork and the impact that that has on performance marketing. So I think a fair question to ask is, what is performance marketing for those that don't know? In a nutshell, performance marketing is just paying for measurable results. And in order to measure those results, we actually need device tracking. There are two identifiers that Apple allows us to use. One of these is identifier for advertisers, or IDFA. This is a universal identifier that's passed amongst all advertisers and publishers and gives everyone a common language with which to track a device. Now, users are able to reset their IDFA if they wish, or they can opt out altogether, and roughly 30% of people do. The other side of this is IDFV, or identifier for vendors. This is actually a publisher-specific identifier, meaning that all games under the Zynga umbrella would see one single identifier for a device, but some other publisher, for instance, King, would see a different identifier. And so we're not able to talk to each other about this player because we don't have a matching identifier. In the performance marketing world, IDFA is obviously going to be the more important one. This allows us to track a user from the initial ad impression all the way through the click, the install, and all of the down funnel actions that a player can make. From the advertiser perspective, this opens up the possibility to make machine learning models. They can take all of the device and user information that they have on their side, they can marry it with the app signals that we have on our side, and they can create machine learning models that optimize on these signals and try to provide us with the traffic that we desire. From our perspective as a publisher, what we can then do is we can take multiple advertisers that we're working with and we can track the spend that we give them and see what we get from it. So we can track all of the down funnel metrics that players contribute. We can then look and see which advertiser is giving us the best installs at the best price, and we can allocate our spend based on that. That's more or less how performance marketing has worked. Networks are trying to find the best ways to efficiently get us the traffic we want. We're trying to find the best efficient ways to spend our money across the various networks. And then last year, Apple came out and decided to deprecate the IDFA. I should say effectively deprecate the IDFA. The IDFA will be around still. In its current form, the IDFA is actually an opt-out identifier, meaning that you, by default, have it turned on and you have to go dig through your settings and find it to turn it off. That's going to change very soon. Apple is now going to make it opt-in, and they're going to make it per app. And so that means every single time that you install an app, you're going to see a prompt that asks you if you would like to be ad tracked. And most industry experts agree that the vast majority of people are going to say no to that. And so much so that the IDFA will no longer be something that we can use as an ad tech piece of identification. And so what's this world look like without the IDFA? Well, without the IDFA, we no longer have overlap between advertiser identification and app identification. And so this chain is broken. Advertisers can't see anything after the click. Apps themselves can't see anything after the install. It's a crushing blow to performance marketing. Apple's aware of this, obviously, and one of the things that they posted when they announced that they were doing this was that they were going to have their own solution called the SKAdNetwork or SKAdNetwork or SCAN. There are a few names for it out there. This SKAdNetwork is supposed to give advertisers and apps the ability to communicate with each other again, but it's supposed to do it in a much more private way. So how exactly does the SKAdNetwork achieve this privacy? It actually has a few things that it implements in order to do this. First of all, there's a severe restriction put on all of the data that's allowed to pass. Whereas the pipeline used to be more or less wide open for apps and advertisers to communicate with each other, Apple is now allowed only 6 bits of information to be passed. Now you can convert this into 64 unique conversion values, or CVs, but you'll only be able to pass one value for each install. And what's more, Apple has decided the conversion value can only increment. And so if you're going to change it from conversion value 20 for an install to conversion value equal 21, you better be sure that you want to do that because you can't go back down to 20. Additionally, Apple has implemented some random timer logic on when they will pass this network or this conversion value back to the advertiser. The idea here is that this way timestamping can't be used to try and identify you either. The network will, at some random point in the near future, receive this conversion value, and that's when they'll know that they got an install. And to make things worse, the conversion value itself will have no identifying information at all outside of the source. And trying to do something like game the conversion value to give you some kind of identifier, for instance, making a very rare event that only somebody, big whale or somebody who spends $1,000 in the game or something like that would do to try and identify that single user, that won't work. The conversion value will actually return a null if there aren't enough users firing that conversion value. And so we live in a world where we can no longer do user level mapping between the advertiser side and the app side. So advertisers' whole pipeline for machine learning is broken. What they'll have to do is they'll have to rebuild this using the SKAdNetwork. They'll have to take the CVs that the apps pass to the SKAdNetwork and then learn how to optimize with those. Now, not being on the advertiser side, it doesn't do that much justice to me to try and explain that and the different techniques out there to try and optimize. And so I'll go ahead and just pass on the advertiser side and talk about what that does to us as publishers. So we're still receiving all of the down funnel metrics that a player contributes. So as they enter into the game, they complete the tutorial, they level up, they make a payment. We're still collecting all of this data, but we've lost the ability to tie that user to a specific network, which means we can no longer tie those actions to that network. And it makes it difficult for us to be able to optimize because we know that this advertiser is taking money from us, and we know that it's producing installs, but we don't know which installs. And so we don't know if they're producing high-value installs for us or low-value installs for us. The whole point here is that the SKAdNetwork is supposed to be our way of funneling this through. And so I think that gives us the opportunity to take a step back and say, okay, what is all of this privacy actually costing us? And it's true that it's costing us a bunch of data. It's severely restricting the amount of data that we can pass back and forth and the way that we can communicate with the advertisers. But all too often, we get stuck in this rut where we confuse data with information. Data itself are just event responses. We collect them and cache them in a database somewhere, hoping that they'll be useful sometime in the future. But it's not until we actually distill the data into information that it becomes actionable. And so while it is true that the data itself, if you increase it, you see a potential increase in information, or if you decrease it, you see a potential decrease in information. It's not a proportionality. Doubling the data doesn't double the information. Having the data doesn't have the information. And so what it becomes as a mission to us is actually to figure out how do we preserve as much information in as little data as possible. It's sort of a compression exercise. I like to think of this as an autoencoder where you're pumping a bunch of data through a neural network. It's reducing it down to the smaller dimensional space. And then that's what's going to be passed around as the conversion value. We then have to figure out how to decode that to the essential information that we need to be able to optimize on our side. And so let's do that. Let's talk about the encoding step first. We need to encode as much information as possible into the data. And there are basically two ideas that have floated around in the industry right now, potentially more, but two large ones. The most popular of these is event-based conversion value mapping. And what this basically means is you take the thousands of individual events that users could possibly fire on that first day, and you filter it out to just the most impactful 10 or 20, whatever. You then map those to conversion values based on hierarchy. So the least valuable one gets the lowest conversion value, and the highest value one gets the highest conversion value. Now, the pros to this are that it's very easy to implement. We're already firing the data, so you might as well just tack on, hey, send this to Apple, by the way. Additionally, it's quite intuitive. You're following the players along the player journey and assuming that the deeper they get into it, the more valuable they are. The cons, though, are that this LTV is actually not as direct as people would hope. If you try to quantify how much value there is in an install getting to level 50, you find that there are very large error bars, uncertainty bars in what that is actually in an LTV sense. And additionally, we're only able to pass this maximum value. You get one conversion value for each install. And so if an advertiser is trying to optimize and build machine learning models, they're actually going to get leaky data. They're going to be players that reach level 50 that network won't know, or that advertiser won't know about. And so that poses a bit of a problem from the machine learning aspect on their end. The other alternative to event-based conversion mapping is to use something that's machine learning based. And that involves basically taking the thousands of events that we collect, distilling that down into a single LTV estimate, and then doing a very trivial mapping to conversion value, where obviously increasing conversion value means increasing LTV. Now, all the pros and cons here are flipped, as you can imagine. This has a very direct correlation with LTV. In fact, the deviations from LTV are the errors in the model. So reducing the errors directly improves the correlation. And what's more, you're aggregating a ton of signals into one. And so that distillation process that I talked about from data to knowledge or to information there's a ton of data that's being used to distill this information. On the flip side, though, there's some abstraction of the signal origin. As a stakeholder, I'm now looking at a black box. You're giving me an LTV estimate in the form of a conversion value, but I don't quite know where all of the pieces fit to make that. And so the player journey is kind of lost. Additionally, and perhaps most importantly, though, you have to build a real-time machine learning model pipeline. That is a very expensive task. It's a very complicated task. And when we're talking about the speed at which things are changing with the situation right now, you could be caught flat-footed. But let's assume that you pick one of these methods. You pick either the event-based or the machine learning-based. You encode some information into the CV. You pass it to the SKAdNetwork. SKAdNetwork eventually passes it back to the advertiser. Now you have each advertiser with their individual conversion value counts. In this simple example, I just have 4 conversion value counts, but you can imagine having up to 64. How do we decode that into something that we can then use on the performance marketing side? It's actually pretty simple as long as you're recording the conversion values yourself. I can treat these conversion values more or less as segments. I can say, okay, look at all of the installs that have conversion value equal 2. I can then compute the average tutorial completion rate, for example, and see that it's 20% for conversion value 2, and that the total payments average is 56 cents for conversion value 2. I can then repeat this for all of the other conversion values, and this gives me sort of a profile of players that fit that segment. So a profile of conversion value 2 players. I then just have to go and look at the individual counts of each of these conversion values that the networks are returning. I can do a weighted sum of these, and I'll recover estimates of these KPIs that we use in traditional performance marketing, such as tutorial completion rate and total payments for each of these advertisers. And so we've actually done this with a sample of data just to see how good or bad it would turn out, because we don't want to live in a world of theory when we're about ready to pump the millions of dollars that goes into performance marketing. And we're shocked that it actually isn't that bad. This is using an in-house machine learning approach for the CV mappings. After 24 hours, it quits updating. Like I said before, the higher conversion values reflect a higher LTV. From here, we can then use these conversion values when they get back to us to map to the down funnel metrics that I discussed earlier we use to traditionally evaluate network performance. In this specific case, I grabbed revenue after day 7, average revenue after day 7, because that's one that is very noisy. There aren't a lot of players that pay at all in mobile gaming, and so the variance is quite large already. And what we end up seeing here is that we do pay some uncertainty in order to afford this anonymity. It actually should be kind of expected because we're talking about a mixture distribution as we pass these values across these various conversion values in the weighted sum. But to me, this actually highlights something more important that we've looked over for a long time, which is that in the performance marketing, and in a lot of industries, we are very overconfident in the meaning of deterministic calculations. So if I can take these 35 installs that we get from a particular advertiser and calculate the average, that people is seen as an exact number. But from an information perspective, there's some wiggle room around there that we're not capturing. And so what we're sort of doing is being faced with something that's been there forever, but that we've been able to ignore until now. We are now in the world of just pure estimates. And so we need to find a way to account for that uncertainty when we're making these decisions moving forward. So what's next? I think on the encoding side, some of these are obvious and exciting, but not that much to talk about here. We need to continue to improve this conversion value encoding correlation with LTV. We need to make sure that conversion value more and more links to the LTV of the player. We also need to tune this conversion value mapping so that we meet those privacy thresholds. If we set this up so that Apple is just firing nulls to all of our advertisers, then our advertisers are never going to be able to optimize, and that's a huge problem. To me, I think the more interesting pieces, though, are actually on the decoding side. As I mentioned, this uncertainty needs to be accounted for. We need to know when we don't actually know and when we do actually know, when we take prescribed actions. And so figuring out how to inject that into conventional decision-making on the performance marketing side is a really important thing. And I think that in order to do that, we're going to need to lean more on machine learning than we ever have to distill all of these signals coming in and try to regain some of the certainty that we've lost with the introduction of SKAdNetwork. This last point I really want to drill home. This is the current paradigm that we have with performance marketing. A performance marketer, is handed a pile of KPIs from the game data and from the advertiser side. They let these numbers swirl around in their brain, and then they take a prescribed action based on that. What I'm proposing is that we need to move people further down the funnel. The reason for this is that the nonlinearities between these metrics, the covariance that exists there, are actually additional information that we very rarely are able to incorporate in our internal calculations, computations that we do in our head. Machine learning models, on the other hand, are extremely hungry for any form of predictability that they can derive, and so they will gladly look at all of these covariances and take them as additional information, and that way we can regain some of the certainty that we've lost. Now, I think that moving people further down the decision funnel past this computation step is also important because it gives people more of the pilot seat that I think they're actually looking for here. We as analytics professionals, as marketing analytics professionals, are no longer in the position of saying, here are some numbers, go do what you got to do, which is a vast landscape for a person to explore. We're now saying, based on these numbers, a machine learning model has produced some recommended actions. Here are those recommended actions. The person can then ingest those, compare them to the business needs, prioritize, and then take those prescribed actions from there. Thank you.
Thanks, Jacob. We've got some great questions from the audience, so let's just dive right in. First one is, how does this impact your treatment of Android installs?
Oh, yeah. So the two main platforms that we work with, iOS and Android, this is all just iOS. So Android is business as usual for now. I think especially at the end, the piece about how we incorporate more machine learning into our decision-making processes, that's something that's agnostic. And so we should be trying to incorporate Android into that also. However, we're less up against the gun with Android. They're going to continue passing data as usual. There are multiple arguments made on either side of swords whether they would ever change that or not. Yeah, right now we're okay on the Android side.
That's great to know. The next question we got from the audience, what are the recommended actions that your ML models would be attempting to evaluate?
Yeah, so most of this discussion here has been about more or less assessing if an advertiser is performing well or not. And it's very true that's important to know, but what's more important to know is what to do if one is not performing. And so there are actually multiple options. There's the very simple option of adjusting budgets, the theory being that decreasing spend will increase performance. But there are other things that we could do too. Within each of these advertisers, there are multiple levers available, such as changing the bidding, the bid size that you would have for an install, or changing the targeting strategy, or just refreshing the ads because they're stale and people are tired of seeing them. And so being able to navigate across each of these and present where there is likely more opportunity as an action, that's really where we would like to drive this in the long run. And I think that being able to pass those pieces to a decision maker and allowing them to weigh that against the costs that would come with each of those methods is sort of where I think we want to put people when we say we want to put them in the pilot seat.
Fantastic. I think we've got time for one more. It's a little bit of a long one. So it sounds like you've given your proposal of moving ML models above people that you believe there will be less room for error and potentially better results yielded as an answer for what actions to take. Would you agree that this is the goal?
Yeah, so I think that the biggest problem that we've had so far in this industry is largely that people as ingestors of data can only ingest them simply and can only make simple decisions from that. And we're at the point where the data itself is squishy now in a sense. And so we are now looking at a landscape where it's not quite so black and white on all of these estimates. And that's just difficult for people to do. And so I think that moving people to an area where it's basically been kind of pre-cleaned, the decisions have been pre-cleaned, is where I think everybody will benefit more. It'll also open up a little bit more of a hypothesis-driven approach to how we tackle this, because with that analytics layer, it allows us to do more rigorous testing and so forth.
Great. Well, thanks so much for today. This information has been very valuable, and we genuinely appreciate you taking the time sharing it with all of us. So with that,
thanks.
Everybody meet us over at 4:30, where Taeyong from Condé Nast will be sharing his information about a non-linear embedded framework with interpretable features for content personalization. We will see you there. Thanks.